So I'm supposed to be the optimist guy. But I will start with Murphy's Law. The light at the end of the tunnel is not the end of the tunnel, but the oncoming train. This message is the one we receive every day when we turn on TV news, the newspaper. Crisis, recession is everywhere. But the future is not doomed. And I'm here to tell you more about the big data and how this big data revolution may revamp the lives we're living in. The definition is vague, controversial. To make it concrete, I wanted to show you this set of 23 chromosomes. This is a chart I received from the NIH, the largest consortium of public research centers in the world based in the US. They have identified in 2005 one genetic mutation related to a specific condition called age-related macular degeneration, causing blindness. The year after, some other mutations also correlated to the same condition, schizophrenia, cardiac disorders. 2007, first quarter, second quarter, third quarter, fourth quarter, 2008, and I stop here because I don't have enough space for that. But you see my point. My point is that this is a fantastic news, but how we're going to deal with such a massive flow of genomic information. And this is so important, because we are not dealing only with genes. We are also dealing with our cells, our organs, and our body. And the scalability of the data sets involved are very, very impressive and staggering. This is a piece of art. Wonderful body. This is Michelangelo's David. And this is the same body, a few years after a diet in the US. Not exactly the same shapes. Still, this is the same body, the same chromosomes, because there is a constant interaction between nature and nurture. This is the text, the genotype, and the context is the environment, the diet, the pollution, smoking, radiations, and so forth. And this is constantly reshaping the text. So this pervasive, regular, permanent interaction between the text and the context is what geneticists, what medicine has to tackle today. So we are now breaking the sound barrier of genomic data. We are dealing with biobanks storing those data, those samples, barcoding signatures. Next year, almost every single cancer patient will be fully genotyped. And 2-3 years ago, we were dealing with petaoctet. Now we are dealing or about to deal with zetaoctet. That's very important. That's basically another dimension in terms of embracing, crunching, analyzing, stockpiling those data. And actually, resequencing the genome is cheaper than stockpiling your genome. That's also fascinating. So there is a next generation gap. The cost of sequencing is plummeting, but there is a bottleneck. The cost of interpreting the data we have sequenced is skyrocketing because we are lacking the intelligence, the resources, the people trained to really capture the essence and the information of this raw material. This is the cost per genome, and you see the Moore's law for a given price. Chip information capacities are going to double every 18 months, but for the genome, for a given price, sequencing capacities are doubling every 5 months. That's why you see this inflection point here. So we have now this new era, translational research. Science, on one hand, and just few years after, not decades, few years, sometimes few months after, the industrialization of those discoveries, the economist. And in between, the big data. We are now forced to reinvent the classic Euclidean mathematical models we used to deal with. So we are also redesigning new tools, new methodologies to approach those data. Still the same problem. You know, in data analysis, there are 4 stages. What is it going on? How is it working? What's going to happen? And how can I make a difference? Descriptive, diagnostic, predictive, prescriptive. So that's almost the same problem. The difference is the magnitude. And this magnitude is even accelerated because we have so many convergent technologies that are going to transform not only our mindset, but also to impact other technologies. Surgical robotics, artificial intelligence, sensors, networks, nanotechnologies, and genomic engineering. We also have 2 major assets to tackle those issues. Do-it-yourself entrepreneurs. We call it DIYers. And those entrepreneurs are creative thinkers, yes, but I prefer to call them valorous. The valorous, because they are creating value. Jonathan Rodberg, some people here in this room who are working for Roche probably know this guy. He pioneered a new generation of genomic chips, DNA microarrays, by using the Intel technology based on semiconductors to screen more rapidly and in a cheaper way DNA. So this is a revolution. Nick Goldman, bioinformatician, that now is working on archiving your family pictures, your books, your DVDs, your music, everything, not on discs, not on tapes, not on Betamax, on DNA. And basically, it's about digitalizing information and converting it into a natural substratum, DNA, that was originally meant to store a massive flow of information in a stable way. What we need for that? An Eppendorf tube, 1 gram of DNA, can stockpile the equivalent amount of data of 1 million DVDs Blu-ray. What do you need for that? Darkness, to prevent mutations, and coolness, because this is how DNA is stable. And we all have this at home. It's called a fridge. Venture, who not only accelerated dramatically the achievement of the human genome mapping, but also who 4 years ago performed something incredible. He created artificially a minimum genome and injected it in a cell cadaver. With electric shock, the cell restarted to divide again. This synthetic genomic is something absolutely incredible because with this, you can produce probably biofuel, but you can also, with this technology, produce vaccines in 48 hours compared to the 2 or 3 months that is today the common standard. Page Brin, Calico. The fact that now Calico is led by Art Levinson, a former founder, CEO of Genentech, and the fact that now they are tackling longevity. And venture is in this race for longevity with this new startup called Human Longevity, who's working on the microbiome, who's working on stem cell reprogrammation, and who's basically also centralizing the largest collection of genomes sequenced worldwide. Jack Andraka is also a source of optimism. This 15-year-old teenage has revolutionized the diagnostic industry. His uncle died of pancreatic cancer and has been working day and night to understand why is it that for pancreatic cancer we don't have any diagnostic technologies. And he discovered a biomarker, and with nanotubes geared with antibodies, he now is prepared to sell, thanks to Johns Hopkins University, those diagnostics for just cents, early diagnostics for pancreatic cancer. Dean Kamen, Skywalker, he looks arm. You know this hand prosthesis? Shinya Yamanaka, the guy who's rebooting our biological clock, who's capable of reversing the process of aging. Yamanaka is probably the greatest Nobel Prize of all time. Mark Zuckerberg and Bill Gates are technophilanthropists. You know that Zuckerberg is also investing in education with his foundation, Startup Education, $120 million, and Gates, $40 billion for health programs, essential medicines and vaccines throughout the world. Entrepreneurs, technophilanthropists, you have all the ingredients. You have dry paper and you have a match. And actually, the problem is that we cannot anticipate what's going to happen because we have a limited linear brain and we are dealing with exponential transformation. It's just like if, literally, we have a blind spot for this technological transformation. We were dealing, like 4 years ago, with 5 exabytes of information produced every 2 days, sorry. And now it's every 10 minutes. Of course, we are exhausted, but when you apply this revolution to the health system, then you understand that the system is completely obsolete due to drug side effects, due to misdiagnosis, due to the fact that medical records are still handwritten. Incredible. And you see the consequences of this. Omissions. You don't record drug interactions because you cannot trace what were the prescriptions before, patients' occupations, and so forth. So it's not only a matter to treat patients, but when you have also those materialized records on the shelf, and you have a catastrophe like a hurricane, suddenly you have 1 million of patient charts that are destroyed. And the patients there, they have survived to this catastrophe, but they don't have any record anymore. That's why we need something else. And what is it exactly? We need to turn on the light. We need an integrated healthcare wallet. What we need is a health version of FedWire. Every day, this system transfers sensitive information, but safely, securely, efficiently. Why is it so difficult to apply this in the health business? This is what Obama has done with the High-Tech Act, with carrots, incentives for doctors who are embarking in adopting those electronic medical records, and sticks with penalties for those who refuse to adopt it. Look at the figures, $19 billion. And the first message is, you should be ready by the end of 2014, now. And the US Centers for Medicare and Medicaid are walking the talk. They are using electronic medical record to optimize their purchasing procedures, also monitor fraud, abuse, compare quality of care, use it for KPIs, to outsource research by giving access to those databases to researchers, increase transparency, but also protect privacy with aggregation and encryptions. This is something important, because this is one of the major social breaks. Everybody is afraid of privacy, about leakage. There are ways to deal with that, and we are dealing with that. We have solved those problems for years, and with the banking industry. So it's a no-brainer that we can cope with this. Now, we can extract health data, we can harmonize them, we should also analyze them, share them, value them, and probably upscale the system. But there are also risks. And the downside risk is silos, fragmentation of IT systems. They are historically fragmented in hospitals, but also social breaks, fears about stigmatization, discrimination. And this is the case for the assurance maladie. France is probably lagging behind because the people at the Ministry of Health, first, are afraid of disclosing those data because they are afraid to discover that they could have anticipated some major blunders, and suddenly they will turn on the light and everybody will look at the way they have managed healthcare so far. So we need now to correlate the pay-for-performance scheme that is applied for drugs to hospitals. To optimize performance, we need real-life data, and this is the big data revolution. I strongly advise you to look at the ICHOM, the International Consortium of Health Outcomes Measurement. This initiative, run by Harvard Business School, the BCG, and the Karolinska in Sweden, can make a difference because they are really taking into account the outcomes that matter to patients. Because when you're a patient and you go to the hospital, you definitely know that hospitals are not equivalent. Doctors are not equivalent. It's just like the shop or the hairdressers. You have better than others. How can you compare this? So basically, we are looking at something that is very old-fashioned and obsolete. Today, payment and outcomes are not aligned. You are not rewarding excellence. You are just paying the same amount of money as a primary payer for everyone. Coverage is certainly equal, but not quality of care. And as a patient, what I want to know is if I go to this hospital, will I get a better treatment? Will I be re-hospitalized 3 weeks after because there is a problem? Will I get side effects, prostate cancer, incontinence, impotence, breast cancer? Will I get any relapse? To prevent this from happening, there is also tools, Watson, IBM. And this tool enables doctors to make better diagnosis, because Watson is basically analyzing the literature and crossing thousands and thousands of clinical cases. The question is, do you want to get diagnosed by a physician who does not have access to Watson? Picasso used to say that computers are useless. They give only answers. Well, they also raise questions. And the point of this conference today is turn on the light and empower patients also. So patients are empowered, and the adoption of electronic medical records will go faster because of genomic technologies that are pre-dematerialized. To conclude, in one word, 33% of people in this room will declare a cancer during his or her life. Sorry to say, but 146 genetic mutations account for nearly all of the major conditions. And more than half of you guys, and myself included, are carrying at least one of those 146 mutations. This knowledge is not actionable now, but many therapeutic solutions are here. Devices at the patient bed, biomarkers approved by the FDA, companion diagnostics, the fact that drugs that were rejected will come back again, and the rebirth of all drugs will come back because they will address a certain segment in the population. We cannot solve our problem with the same thinking we used when we created them. To conclude, the last word would be Archimedes. Give me a lever long enough and a place to stand, and I will move the world. Pessimism is only for the ill-informed. Thank you.